Hi, my name is Brad Friedman, and today I'm going to show you a quick demo for artists and designers of OpenCL Tools in Unity, which is a new product that hopefully will make it to the asset store relatively soon. Should be noted that there will be another video or session for developers that will start bottom up as opposed to top down and be much more technically oriented. Okay, so here I have a Unity scene. And I'm just going to hit play and show you what it does. It's going to take a second to boot up here on my really slow and old MacBook Air that is also doing Camtasia. So here it goes, and what it does by default is it flashes random colors on this cube, one per frame, which is not a very impressive thing. This is a very simple demo just to show you in basic terms how this works. If I go into this asset and to its arguments and grab my fill color argument, you can see here I have two behaviors, one called color parameter argument and one called random CL color. If I turn off random CL color, it just freezes. If I turn it back on, it starts going randomly again. But for the moment, I'm going to turn it off and just grab the color parameter. This is just a standard Unity color parameter, and just start pulling it around. You can see that it follows around in real time. The point of this, really, the reason why I'm taking it and moving it around in this way, is to show you sort of the point of all of this, which is that there's a lot of complex OpenCL constructs going on to make this work, but at the end of the day, what it's doing is it's rendering a color to texture, and it's exposing the parameters for that to you in standard Unity ways, in ways that are going to be familiar and familiar to you and you'll be used to working with, rather than making you dive deep into programming in order to control OpenCL. That's the point of this. All right, so I'm just going to turn my random CL color back on just to show that it's still going, and then we're going to stop this, and I want to show you a little bit more about how this is actually constructed. Okay, so we have here, first of all, at the very top level of the scene, we have our main camera and our point light, and there's nothing special going on with either of these. And then I have two other objects, game objects. I have CL test asset and I have CL global. We'll take a look at global in a minute, but first I want to look at the CL test asset, which is basically just my cube. Underneath it I have CL and Geo. Geo is just the cube, and there's nothing special going on here. It's just transform, cube mesh, box collider, mesh renderer, and a material. And the material has a texture on it, which right now is pink, but it's going to change randomly. Under CL in the asset is where I'm keeping all my OpenCL stuff. Okay, so if we open up that way, we have args, which is where I went to change the arguments or parameters that were sort of being used by OpenCL. I have kernels, and I have queues. Now, you don't have to use these names. I'm just trying to keep it organized, but I think this is a pretty good way to start. So let's just take a look at the top level CL object for a moment. There are two behaviors on here. There's CL context link, which we'll get to a little bit later when we look at the global. But most importantly, we have execute queue on update, and this is really the most important thing. This is the hook. This is the thing that actually makes OpenCL do something. It's executing the queue on an OpenCL queue on every update. Which queue? It's executing a queue called test queue, and if you open up queues, you'll find that I have an object called test queue, and it has a thing on it called a CL execution order. Okay, so on every update we are running this CL execution order, which makes sense because that's how you get it to do something every frame. Within this, again, we have a context link, which we'll get to in a minute, but most importantly we have a queue, and the queue is 2 elements long, and at first it has a render image step, and then it has a copy image step. And the reason for this is because first it needs to tell OpenCL to render the image, which in this case is fill it with a random color. And then it needs to tell it to copy it out of OpenCL memory and into Unity memory. And those are the two things that are necessary to do every frame in order to get it to change its frames randomly. If we open up the test queue, I have another object in here just to keep organized called steps. And then we have those two steps that we just saw, render image and copy image. So render image runs first. We'll take a look at it, and I guess we'll just run down these things real quick. Actually, I think I'll probably skip over most of them. But dependent steps, none. This is the first step in the queue, so it doesn't need to wait for anything else to get finished in order for it to be done. Kernel link. This is where it links into the actual OpenCL code. You notice it's got it's referencing fill image kernel, which if we go up here into kernels, you'll see that I have a kernel called fill image. Where is it getting its code from? We'll get back to that when we look at CL Global, but the important thing here is that we have a kernel in this object called fill image that does that job, and here we are actually linking it into a kernel step to make it run. Okay, I'm going to skip these OpenCL specific parameters because they're really actually very specific to this implementation, but this is also one of those areas where developers on your team can probably simplify things for you. But at a low level, to run when you run an OpenCL kernel, usually it's a multi-dimensional, three-dimensional kernel. And in this case, we're telling it to run in 3 dimensions with a size of 256 by 256 by 1, which is the size of the texture. It's nothing particularly crazy. Copy image. Is something that I built to help copy things out to Unity textures. Dependent steps, it's dependent on render image. When you say that, it keeps it from running before render image is done. It's going to complete rendering the image before it copies it out to the texture, which will be important so you don't get tearing. It has a place for the CL texture, which up here in arguments, I have my render image, which was the other thing here. Which is creating the image in OpenCL's memory. And so it has parameters for its size. And so that is something that needs to reference, or needs something to copy from. It's got the Unity texture, which is blank for the moment, because that's for you to see at runtime, but it's basically just grabbing the main text out of the cube material, which I've referenced. You know, where they come from? They come from the geo. Big surprise. And so image to texture queue step is going to copy things out of the CL image into the texture on every frame, and the reason it's doing that is because it's part of this queue which is running every frame. Okay, so we've sort of gone through all the components of the asset, which is we've got a color argument that we need to feed to OpenCL in order to tell it what color to fill. We have a render image argument, which is just the OpenCL image that it's doing its work on. Okay, we have a fill image kernel, which is the thing that's doing the work. And if we take a look on its arguments, it has the color as argument 0 and the image as argument 1, so that it can do that work. Okay, we've got a queue, which I'm calling test queue, which has 2 steps in it, which is render the image, then copy the image. All these things are referencing each other to make a little machine that basically just creates a texture of a different color every single frame. Okay. The important thing to note here is that there's no code involved in this. You know, as an artist or as a technical artist, building one of these things and pointing your artists to the arguments and just naming them and telling them what they can do to customize their asset is sort of the goal, so that they don't have to worry about code beyond that. Okay. But nonetheless, as a technical artist or as a programmer, you sort of need to know how to get your code in there, and that's where we get to this CL Global, which is sort of a central object to represent the sort of the OpenCL engine for this scene. Okay, at the top level, it's just an empty object because I'm just organizing this way. The next thing is a CL context. Context is the very base level sort of system. Collection of devices and memory space that OpenCL is managing. And you need to create it. In this case, I've created a CL simple context and told it that it's allowed to create GPU devices, accelerator devices, and CPU devices when it's creating that context. You need one of these if you're going to run OpenCL, because you have to have some sort of context in which to run OpenCL programs. Next step in this is a program. I have, again, a thing here called a CL simple program. In order to compile a CL program, it needs to be in a context, and that's where these links come in, okay? Which is that it needs a context link, a link to some context in which to exist. And so I've got a lot of options here for how you find a context so that the program can compile. You can search by name, you can search by tag, you can search for it on yourself or your parent objects. You can search by an explicit reference, which is just dragging it into the reference field. Or you can say that it's a scene singleton, which means that there's only one in the entire scene, and you should just go find it. In this case, I have it set to parents or self, but actually scene singleton will work just as well because there is only one context in the scene. These fields are useful, for example, if you do by name, you can put the name in here to search for, etc., etc. The reference you can just drag in here, if you're doing searching by ref, and then it'll update when you run. It'll tell you if it was found or not, and that's for debugging purposes, so you can see what's going on. So we'll just go back to scene singleton. I have a read-only list here that's just going to show you the number of source files that it finds, and that's perhaps the most important thing to show you next, is these little source files. Okay, fillimage.cl and helloworld.cl. These are actually, in my examples folder, these are little text files, fillimage.cl, helloworld.cl. And I have a custom importer running, or post-processor, which anytime a .cl file in the project is updated, it's updating a prefab that sits right next to it with a little CL source code behavior on it, and it just reads the source code directly, and it keeps it up to date automatically. You don't have to worry about it. You just drag these little prefabs over to the program, and the program just looks for any children that are of this, that have little CL source codes on them. It collects them all, and it compiles them when you run the scenes. So that's how we go from code, which is actually sitting in your assets folder that your developers would keep in order, and sort of get it hooked up to devices and compiled at runtime in a central location. In theory, this CL global object is something that technical artists or developers would keep up to date. It's probably a prefab in its own right. Artists and game designers don't need to worry about it if everyone's working correctly. The only thing they really need to agree to is the names of the kernels and the arguments in the kernels, so that assets can use them appropriately. And when all that is put together in that way, we get this, which we'll run in a second on my really slow MacBook Air. A randomly flashing cube. Okay. So that's where it sits right now, which is sort of in the middle between perhaps not necessarily a dirt simple stupid. You do need to understand certain parts of OpenCL in order to use this effectively, but right now it sort of creates an environment where a technical artist who does understand OpenCL well enough to collaborate with a developer who absolutely understands OpenCL can create assets and provide some arguments for artists to tweak who don't know anything about OpenCL, which is a pretty good start. As we go into the technical details, as developers will see, this system is designed to be simplified by developers, such that you can end up with all of these behaviors. A lot of them are prepended with the words simple and abstract, and the reason for that is because they're meant to be extended by developers to create even simpler versions of these kinds of behaviors for technical artists and for artists to use, such that a lot of this complexity can actually be hidden even further. All right, so that's a very top-level overview of a thing that's coming for using OpenCL in Unity 3D.